problem, convert sorted array to binary search tree. So this problem is categorized as a Google phone interview question. So in this problem, you'll be given an input array which is in sorted order, and you need to convert into a balanced binary search tree. So balanced tree is the one where the height of the left and right nodes are less than 1. So it's a case where you could essentially create a binary tree where, since it's in sorted order, you always add the right child to that tree, and it'll be a valid tree, but it's not balanced. So yeah, to find the balance, they're giving us a few examples of how they want us to create the tree. So here's an example where the input is -10, -3, 0, 5, 9. So they selected the midpoint to be the root of the tree, and then they recursively call it where, the one which is on the left will be anything to the left of the root, and everything on the right is on the right child. And they keep doing it until they have created the entire tree. So yeah, to solve the problem, anything which is in sorted order, I think the best algorithm to use would be like the binary search algorithm. So yeah, let's try working on that solution. So to solve this, let's create a function which can be called recursively, and that will be used to create the nodes of the tree. So I'm just going to call this, use the same name as the other method. And in this, we'll pass the argument, the integer array, and the left and the right pointers. So like all recursive functions, we need a base case and a recursive case. So the base case would be if the left is greater than the right. That means we have processed all the elements on the left, so there's nothing more to process. So if we return null. Else, like other binary search algorithms, what we are going to do is we are going to create the midpoint and use that to return that as a root of the tree, and then recursively we are going to start processing the left and the right half of the array and do it until all of the elements have been added. So so it's left by right, and so we're going to create a tree node. So here we're just using this helper class that defined for us, where to create a tree node we can just pass an integer value, and so yeah, that's what we are doing right here. After that, we now need to create the left and right child for this tree. So here we are going to call this method recursively. So you're going to pass the input array, and for the left child, since we have already processed the midpoint, left will remain the same, but the right will be equal to mid minus 1. So that's essentially what we are doing now. So given this input array, so we have processed 10. So the left child, we're dividing the array into the left half and the right half. So the left child will be either -10 or -3, and like that we keep calling it recursively until all of the elements are added. Similarly, will be the same. But here, since we have processed midpoint, we'll say left plus 1. Oh, sorry, mid plus 1. And we're going to return the node at the end. So here we'll just call the function. So return so recap, what we're going to do is we are going to use a recursive function where we essentially will find the midpoint, and we'll use that as a source of root of the binary search tree. And then recursively, we'll call the method where we pass in the left and the right half of the array, and we'll keep processing it until all of the elements have been added. Let's try running it. So yeah, the time complexity will be O of n, where n is the number of elements inside the input array. Same thing, the space complexity will be also O of n, since we are creating a binary search tree of size n.